Hilltop Hydro can produce a range of hydrological tables, and I'm going to talk about some of them here, starting with hourly statistics. Here's a table I prepared earlier. There's a column for each hour of the day, and a row for each day of the month, and the totals are shown too. This is repeated for each month. I'm looking at rainfall here, and being incremental data, these values are hourly totals. Let's look at how we make a table like this. We go to Table, Hourly Stats, choose your data and the time range. Okay, let's not look at 15 years worth of data. 3 months is a little more manageable. We have the option of adding a label and applying a linear transformation. We need to choose a statistic, and what's available depends on the type of data we're looking at and its interpolation method. So for rainfall, it's the total per hour. But if we were to look at flow, for example, then we could select the lowest, average, or highest value in an hour, an interpolated value computed at the beginning of each hour, or the amount of missing record in each day, shown as a fraction of an hour. In the case of missing records, you can enter the maximum you'll accept and still consider the result valid. Anything more, and Hydro will put an asterisk in the table. Ticking here will fix the format of the numbers in the table to what has been defined in the measurements table in Manager, and you'd normally use this option. Otherwise, Hydro will write the values to 4 significant digits, and for values larger than 4 digits, we'll add instructions to the table on how to read the results. Use wide format as it expands the columns across the page and increases the number of characters allowed for each value. Select Center Clipboard if you want to be able to paste your data straight into Excel. The hourly stats process is most often used for rainfall data because it gives an indication of intensity and the grouping of storms. If you find your data is all over the show and the columns don't line up neatly, you can fix this by changing to a monospaced font. Go to Table, Options, Font. I'm using Lucida Console. If you don't have this, another good one is Droid Sans Mono, available free from Google. Let's now have a look at the daily statistics table. It has a column for each month of the year and a row for each day of the month. The monthly minima, maxima and totals are printed below. This is repeated for each year. Let's recreate this table. And again, the available statistics depend on the data you're analysing. Here, the day begins at midnight, but you can change this. Say if you've got people reading rainfall gauges, they're more likely to be doing it at 9 AM than midnight. And if you change that, you'll probably want to change this, or the data will look like it's a day adrift. Carrying on with rainfall, here you can decide what constitutes a rainy day. It's 0 here, as logically any rain makes it a day that rained, but if you're looking for storms, you might want to up the ante a bit. You can set the first column of the table to any month. It doesn't have to run from January. Building a monthly statistics table is very similar to a daily statistics table, so we'll just take a look at the end result. Here we have a column for each month and a row for each year, with the yearly total here. Below are the min, mean and max values for each month and for the annual totals. The values in the table are the mean over the month, or the total for the month if the data is incremental. The means are calendar means, which means they take into account the number of days in the month, if you know what I mean. Let's have a look now at the min, mean, max table. Some of you old-timers may know it as P3, but regardless, I'm sure you can guess what it produces. There are a whole lot of options to select from here, and I want to talk about these fixed interval options. Daily, weekly, monthly and annual min, mean, max are pretty self-explanatory, and we'll take a quick look at a weekly table. It has a row for each week in the time range, and the first row here is week 35 of 1995. Then there are 3 columns showing the lowest, average and highest values found in that week. We'll go back to the dialog and generate a min, mean, max monthly stats table. Again, it shows us where we are by listing the year followed by the month. So this first row is September 1995. Again, we have columns listing the min, mean and max, and we also have these extra stats: standard deviation, 20th and 25th percentile, the median, 75th and 80th percentile. The annual stats option in the dialog produces the same statistics, but for each year in the time range. The distribution over time process computes the cumulative distribution of the measurement and tabulates exceedance probabilities. It will produce graphs as well, but we're going to look at the table side of things. The distribution over time table looks like a good old log table with 10 percentile values for each row. Each of these values is the value associated with the probability of the measurement being greater than that shown in the table. Got it? So for example, flow on the Alphabet River at Crossword was greater than 39.776 cubic meters per second 50% of the time. We also have the mean and standard deviation over the time range, how much data was analysed, and how much missing record is in the data set. This is talking about how the statistics were calculated. First, Hydro divides the data into 50 classes and calculates the minimum and maximum values and estimates the 0.5th and 95.5th percentiles. The distribution is then calculated using 2000 classes with the range set to those percentiles. If you've selected Centre Clipboard, the layout in Excel is a little different to this, with a column for each value from 0 through to 100 across the page. The values are written in the row below. If you're looking at ensemble statistics, there will be a row for each period. Okay, so to produce one of these tables, we go to Table, Distribution. Once we've selected our data and time range, we have to choose which statistic we wish to look at. Actual data will use the minimum and maximum values as they are in the data file for the calculation. Fixed average will step through the data at fixed, regular steps as determined by the time interval that you enter. Moving average computes the average over the specified time interval, but computes the average for each period defined by the presence of data points in the time series. This one computes a distribution of the time between elements in the time series, and it's a good way to check the reliability of a data logger which is supposed to produce a reading at regular intervals. Under the second tab, you can enter values to limit the range of the data over which the distribution will be calculated. Distribution over time will also do monthly and seasonal calculations. If you choose monthly, a probability density calculation is done for each month, and then the statistics are calculated. Seasonal ensemble statistics does a similar thing, but over 3-month periods. To determine the seasons, you choose the start month. So if I choose December, summer will be December to February, autumn will be March to May, and so on. Let's add a duration calculation to see what that does. And we can see that the flow was greater than 100 cubic meters per second for 207 days, which was about 5.8% of the time. That's useful for looking at floods, and if you're looking at low flows, and we'll just go back, you can add a duration below the limit. And conversely, this tells us that the flow was less than 20 cubic meters per second for 398 days, or about 11% of the time.